here. Alright, Ben. But you've been participating a lot less. Okay, so there's only two spots where you can draw that in. Once you come up to the board and show us where you can draw those horizontal lines to break up what's called this is called a compound shape. It's a polygon made up of more than one shape. Cat, come on up. You can do it. Choose red, I think. Red's fine. Pretty great, that's how we put it. Okay, we have three separate rectangles being created by two horizontal lines. So we did exactly what the else did. Our task now is to try to find the overall area after we break it down. So does everybody see that really the idea is that once you break it up, you want to find, let's call this rectangle 1. Put a 1 here in the middle and circle it. Let's call this rectangle 2 because it's exactly the same dimensions as rectangle 1. And this is rectangle 3. What's the formula for finding the area of a rectangle? Length times width. Well, let's stay with base times height, okay? Because you'll see when we get triangles, we can use it exclusively that way. It's just one formula to remember. So everything, they give you 3 lines. It's going to be the 3-step system. I put a little 1 here because that's going to be the first rectangle. Now, as you'll see, the first 2 rectangles are pretty straightforward because they give you the base and height. What's the base? Marcus. No, rectangle 1. Oh. 270, right? Because look, opposite sides are equal. So this is 2, this is 2. Sophia, what's the height? You can. Say it. Yeah, you're right. You're right. Because look, if this is 4, this is 4, so all of our uprights here are 4. Alright, what's our overall area of just that piece? John? 8. And I'm not going to worry about units yet. Leave it as 8, because we have to do something at the end before we even have to tack on units. Al, did you need something? You good? Okay, rectangle 2. It's the same as rectangle 1. We have to write it out. Now, rectangle 3 is when you have to do a little bit of thinking. This kind of builds on what we did yesterday, where you hopefully have to see the length of a piece that you need that's not given. They do give you 1. The base is what? Vote. They give us 7. So let's start off by the formula first. Let's do it red, I guess. Here's where you got to use your noodle and figure out what the height is. If you're calling it, tell me how you did it. Tell the class how you did it. Joe, what did you say? Okay, why do you say 5? Alright, so you took this 4 and realize what? How can you apply that to 4 to the shape that we need? As, come up and just do it. Label everything that you know is 4. How's that? Okay, great. Now, we're almost there. If this is 4, then from here to here is also 4. Now we've got to use that piece to determine what it is from here to here. Well, if the whole entire piece is 9, and from here to here is 4, that's got to make this from here to here what? 5. And again, it might take a little bit longer for you to see it, but you just got to practice it. Alright, so now we have a height of 5. We got everything that we need. What do you got? 35 for that piece. But remember I told you, don't worry about the numbers with different units. Yeah. Leave them numbers, because we have to do something in the final step before we have to tack it on. Okay, this is what the last set of lines is for. What do I have to do to get the entire area of the compound shape? Now, you have to add them all together. 8 plus 8, I'm going to do it in my head. Just make it easier. 16, right? 35, maybe you can do it in your head, but we'll show it. Now what do I have to do in that final step? Say it, Marcus.
Put the units.
Which is meters squared. 51 square meters. Okay. Look at this. Look at the shape down below. Let me ask you this: is it any different from the first shape? It's the same exact dimensions, right? All I'm trying to show you, and we'll go through the steps, is that you can break it up many different ways, and you'll still get the same area. So now they're asking you to divide the stage into 3 rectangles using 2 vertical lines. And then we're going to do the same thing and find the area of those rectangles. First, run up. Do it in green. We'll do a different color so we can see the difference. Now, while you're here, why don't you also number the rectangles that you set? You guys see that also rectangles 1 and 2 are the same? Okay, let's see, what should we get if we do the entire area? What are we supposed to get, Phil? Let's see if it works. Rectangle 1 is first. By the way, before I even start this, look at it. What's going to be the tricky piece? Everybody say, do you agree? 3? And when I say tricky, where you got to maybe do a little bit of thinking because the numbers are not right in front of you. All right, what's the base of rectangle 1? Just say it out loud, guys. I want to hear you. 2, right? What about the height? Area. Does everybody see that rectangle 2 is exactly the same? Even though they don't give you 9 on this side. Opposite sides of the rectangle, even if there's a missing piece or a gap in the middle, is still 9. Now we got the tricky piece, because they don't give you anything. You have to figure out, by using math, the base and the height completely by using the other measurements. Start with the formula first, that's the easy part. Okay, do you see it? This piece right here is our base. You've got to try to figure out what it is. And I'm going to Troy's because he kind of figured this out, and we need it now. So, Jack, what is it? How did you get 3? There you go. Yes. If this piece is 2, and this piece is 2, you have to say to yourself, okay, 2 plus 2 plus what makes 7? Because our horizontals have to add up to be the same number. So he's right, it's 3. What about the height? Kind of defer to what you did back in diagram 1. Remember what you got? We see that it's 5, 4 is here. From here to here, it's got to be this plus this to make 9. So it's 5. +18 plus 18 plus 15. Do it. Loop. It works. 51 meters squared. We get the same thing. Flip. Oops. Vertical answer. Now they want one going one way and one going the other way. One vertical, one horizontal. There's 2 different ways you can do it. Want to do it. Oh, come on up. That'll work. Label your rectangles while you're at it. Now when you do it this way, you got 3 different rectangles. You don't have 2 of the same anymore. You don't have 2 of the same anymore, so you do have to physically do the base times height with different dimensions for 3 different rectangles. Alright, let's do one first. We can kind of defer to maybe what we did, but you don't even really need to do that because you can see what the length or the base and the height are for one. What's the base? Out loud. Say it. What's the base? 2, right? 2. What is the height? 9. It's right there in front of you. So we got 18. We're up and running. However, shape number 2, or rectangle 2, is brand new. Alright, let's do the formula. Now I want you to raise your hand because I want to see if you're seeing it. It's brand new. What's the base? John, what do you say? John? This wasn't anything like Alex. John? What do you got? See how we got 5?
Yeah.
Base.
Oh,
7 minus 2. Okay, good. Alright, the height. Dylan, what do you got? Also 5.
so square.
Happens to be a square, but don't necessarily make your decisions on those lengths based on how the shape looks, because they may not be drawn to scale. Use the actual math. But do you see why it's 5? Here to here is 4. The whole thing has to be 9. So 4 plus 5 make 9. Yeah, what's 5 times 9? Oh, I'm sorry, you're right, 5. What's 5 times 5?
25.
Great. Alright, and then shape 3, luckily it's right in front of you again, so we're okay. Base out loud.
2.
2. What's the height?
4.
Area is? Alright, we gotta add all 3 numbers. What should you get? It works. Alright, everybody say the word after me. Say decomposition. What do you think decomposition means? It has the word decompose in it. What does that word mean? Alex. Oh, thank you. Okay, we got that. You know what decomposition is?
When you take something apart to little areas.
That's it. It's breaking it up into smaller shapes called decomposition. Everybody say composition. I'm going to show you that way too, because sometimes composition works better than decomposition. With composition, you add a piece into, in other words, here's your stage. Does everybody see that there's a missing piece? So essentially, if we could find the entire area of this rectangle when we close this off, what would you then have to do to figure out the area of what that stage is without that piece? Come on, use your noodle. Dylan. That's it, right? So if you could find this whole entire, make believe this box is not even here in the middle. You find the area, base times height of the whole entire rectangle. Then find the area of the smaller rectangle and subtract that piece. Okay, that's called composition. You do that. You basically close off that rectangle and then use the inside rectangle and subtract that area from the main rectangle. Okay, now, if we do that, they didn't put any measurements here. So what was this whole entire piece right here, up and down length? It was 9. Put in 9, don't even worry about units yet. What was this piece? What was this piece?
4.
What was this piece? Okay. Everybody, find the area of the large rectangle. Do that now. Did you get 63? Okay, who wants to come up and do the smaller piece? What's different about this? We're not adding anymore. What do we have to do? We have to subtract. What take you what? We want them to get a number if you do that.
Oh,
Minus 12. And what do you get?
what's that box?
Is it? Oh, you know why? Because if I put it here, it's probably like a discussion. What do you notice? What do you notice about everything of you all? Like we did 3 different ways. We did 4 different ways. Yeah, right. We did 4 different ways. What do you notice about the answer? Kind of discussing as we go along. What do you get? That's all it takes. So it's a lot of steps, but I want to show you that there's lots of different ways to get the same answer. Yeah, take a break, then I'll finish. You don't need to do anything with this except look and listen and ask questions. Well, something good. It's like straight. It makes sense when you turn straight lines too. Like was it? Okay, so you guys had it with decimals. Well, let me hear from you. Those of you that took it, what did you do? Because you can't do base times height. You can't. It's not a rectangle. You certainly can't do base times height divided by 2 because it's not a triangle.
I got it wrong.
But think for a minute. Think about what the gist did with lesson 4. Think about that word I just used with you, decomposition. If you can put 2 and 2 together, you might be able to reason through this. Code. Talk us through the process. Tell me what you did.
I just made a dotted line, split the triangle.
Okay, let me do that. So right here? Okay. Alright, then what? Okay, so now what's the rectangle? What are my sides of my rectangle? Everybody see why it's 8 and 7? Does everybody see why it's not 7 and 10? Okay? We don't care about the whole length. Our piece, when we close this off and add that dotted line, we have a base of 8 and a height of 7. I have it reversed, but that's okay. What do you get? 7 times 8.
Oh, sorry.
Alright.
I was testing you guys.
Now what? Code, now what? That's the easy part.
Triangle.
Okay, well, what's the base? Does everybody see why it's 2? Because again, this two, right? This is from 10, the whole piece. So it's got to be, and just from here to here is 8. The whole piece is 10. See, another 2 there. It's tight. Opposite sides of a rectangle are equal, right? Area of that piece. Now what? Add the two areas together, what do you get? 63. So, and they whatever square units in this case. But the idea being that, listen, the only difference between this question and the one that you just saw an hour ago or so is that they give these sides in decimals, which is what you'll see a lot on state tests. They combine a lot of different skills together. So they're not only testing, they're testing, think about it, they're testing 3 things. Your knowledge of area and formulas, your area, your knowledge of knowing how to break up a compound shape, and your knowledge of multiplying and dividing decimals. A lot of multi-skills in these questions, okay? So that's the trapezoid. The one I'm going to show you on the next page you're going to go to is actually a little bit more difficult because you have to decide how you're going to break it up. Any shape now that's not a rectangle or a triangle has to be broken up. You can't do straight formula base times height or base times height divided by 2. It will not work. So you have to. What page do you want? I think I wanted you to skip page 7, right? Yeah. I think. Small important. My advice to you guys is the formula part of area, whether it's your base times height or base times height divided by 2, or even you're multiplying and dividing of numbers, you're going to be fine with that. You've done it enough times now with formula, substitute, multiply, divide. The hardest part is knowing how to break up the shape and then being able to recognize and see the missing sides. That's going to be your test. That's what we're going to practice leading up to the test next week. I'm going to give you shapes. Maybe we'll do it as a marker board thing for fun because they're kind of fun. So that'll give you the shape with missing sides, and you got to try to figure out what the missing sides are. The other task is knowing which shape or how to break up a compound shape. So you have your first trapezoid. Well, you have your second trapezoid actually. The first one we did was a little bit easier. This one, how can you break this up? And one more other little thing that I want to tell you. When you get going with this and you're doing them on your own, you want to break up the shapes in as few shapes as possible. You don't want to do extra work. So if you're able to break something up into 2 different shapes, or 2 shapes, that's better than trying to break it up into 3 shapes, or 4 shapes. Break it up into as little shapes as possible. That being said, do you see what I say? How many shapes can you break that up into? Phil, what shapes would you break it up into? You want to come and divide it. Come and do it. Show me. How many shapes did it create by that line? See 2 shapes? What are the shapes? Triangles. You got triangles. Only thing you got to double check and say is, do I have a base? Do I have a height? Or, at the very least, can I find the height and find the base by using my what we've been doing in the beginning part? All right, let's do it. We'll call this triangle 1. We'll call this triangle 2. Create formula for a triangle. You got it. Right? You got to be able to have the ability to reason with shapes that may or may not be right side up. You got to kind of sometimes think upside down with some of this. What's the base of triangle 1? I want to hear from somebody I haven't heard from. Shamika. Come on, you can do this. Base of triangle 1. You can do it. Yes, it's 4. Everybody see 4?
Yes.
All right, that's my base. But you got to kind of think it's. All right, let me turn it upside down. That would be my bottom. That's my 4. What's my height? Remember, height and altitude, same thing. From base to the tippy top, but you got to think upside down. Birds. Not 8. That's outside my triangle. Think from here to here. I did it outside of the triangle because I don't want to give it away. If I did it on the other side of the triangle, it would give it away.
Oh.
5. You got it. There it is, right there. That's what that little dotted line is. That dotted line's got to be in there for some reason. How would they put it in there? They have to tell you that.
Yes.
Do not forget to divide by 2. Okay? Once you get those numbers, man, you don't want to make a basic math error. All right, what do you get as the area of triangle 1? Say it out loud. 10. Triangle 1's done. Okay, number 2. All right, Kat, I'm going to you. Oh, you got it. Base of triangle 2. Triangle 2. 8. Triangle 2, as you see, is going to be easier because it's upright. You see that it's upright, it might come to you a little bit easier. All right, what about the height? Hertz, I'm going to you. You know what's cool about trapezoids? The height will always be the same for both triangles. Little hint, okay? Don't forget to divide by 2. Yeah. Molly. See? I'm learning. Total area of the trapezoid, because you're still not home free just yet. Fuzz. You got it. You remember no naked numbers. We can tack on the units, and we're good. We're going to cheat with this other one. Okay? What if I put the diagonal from here to here? Does it change the area?
No.
Let's just do it mentally. I'm not going to have you write all the formulas out. But look, what's my base? 4. What's my height? What's my area of my triangle? 10. Do it quickly in your head. We were going to have a sprint today, but I decided not to because it was a good job. But we may do it next week where I'm going to give you shapes of triangles and rectangles, and I want you to be able to quickly do it in your head. This is 10. What about triangle number 2? What's the base?
8.
What's the height? What's the area?
20.
20 plus 10? It works. So now you know you can divide that triangle with your diagonal either way and it'll work. Good with it?
Yes.
Alright, so let me tell you what you can do. How much time we got? Let me pause this.